which is just calculating chemical quantities in a reaction, we need a balanced equation. So any balanced equation will do. Has to be balanced because the coefficients tell us the number of moles. It could also tell us atoms, molecules, or formula units. In this, they're all molecules. But the ones we're going to be using most is moles. Okay. So how are we going to use these moles? We are going to use these moles to do a conversion. And these mole-to-mole calculations or mole-to-mole conversions, where we use these mole ratios, that's the basis of this whole chapter. So we can write all sorts of mole ratios. So I've written all the possible mole ratios from that balanced equation. Notice the subscripts were left off because I couldn't figure out how to do it. But coefficient of N2 is 1, so anywhere you have N2 in this, it's 1. So we're going to set this up like any other conversion we've ever done. So we're going to use this equation, come down here and do this problem. So here's what we're given. 1.20 moles of N2. Here's what we want. So we need to use a mole ratio to get between them. What we were given goes to the bottom. What we're looking for goes to the top. And you've got to keep moles, which is the unit, and the formula. With your numbers. That way you can tell what you need and what things cancel. So, our coefficient on NH3 is 2. Our coefficient on N2 is 1. So when we do the math, we get 2.40. So here's another problem. Different equation. Given 3.4 moles H2O2, how many moles of O2? So that's what we're looking for. So what mole ratio do we need? We need moles of H2O2 on the bottom and moles of O2 on the top. We get those numbers from the coefficients from the balanced equation, and so we get 1.7.